Hello, my name is Andrew Ireson and I'm a professor in hydrology at the University of Saskatchewan. And I'm offering a short course in building skills in environmental data analysis and modeling with Python. So I'd like to tell you about the course today. So this is a short course or workshop with flexible delivery depending on the needs of the audience that I will teach. And in this course, we're going to use freely available software to develop skills in data analysis and modeling. The content will depend on the audience, and I can offer a beginner level course which will spend much more time on the fundamentals and the basic programming concepts, things that you can't easily get from ChatGPT because you've got to get those basics understood before you start just using methods. But I can also offer this as a more intermediate or advanced level course for those looking to develop models and do more sophisticated analysis. The general competencies will include using Python to perform reproducible data analysis and modeling, learning how to analyze and visualize large data sets using appropriate tools, always open source, learn how to develop conceptual models of complex systems, and then develop equations and mathematical models, and then solve those equations using maybe a systems dynamics model or a numerical model. And then finally, critically evaluate the model outputs and understand how these can be used to support decision making. What are they actually telling us that's useful in the real world? So I'll just give a few examples now of some of the sorts of things that we'll cover. The first thing is data processing. So data processing is really important, and here's an example from a piece of groundwater data from a piezometer. And this is a fairly messy data set that actually requires quite a lot of processing before you can get the data into usable form. And so in this example, the processing is all done using Python scripts, which means it's fully reproducible. Other people can reproduce this analysis, and I can also, when I get more data, I can simply update it very rapidly by just running my scripts. So it's a very efficient and effective way to work with data. Another thing is data analysis. So there are a whole range of different statistical methods that we use for data analysis. And one of the most important, in my view, is how to visualize data. So simply plotting data in different ways. And I'll put a lot of emphasis on building skills in visualizing data. But also some of the methods, such as this is a simple method, linear regression. And we can do that in Python. And we can go through this from first principles, looking at the concepts of covariance and variance, and how do we calculate the slope and the intercept of the regression line and the Pearson correlation coefficient and so on. Now this is an example using open source data, and I'll talk a little bit about how to obtain open source data, and what's challenging often is how to get that data into the Python environment. So how do we read that data? And I'll teach students how to do that step as well. And then finally, the more complicated area is modeling. And modeling involves a number of stages. The first stage is always developing the conceptual model. Here's an example of a snowpack model where we've identified the processes that we think are important in terms of the water balance. And then from that conceptual model, we then develop our mathematical model. And we can solve that mathematical model in different ways. For example, in a systems dynamics model, as shown here, this is a Stellar model, but there is other software as well, including in Python, that we can use for this. And that's very good for a wide range of problems where you have basically systems of ordinary differential equations. But for some problems, we need to solve partial differential equations, such as groundwater flow, soil moisture. And I've worked on a number of different models like that, including Soilice, which is my frozen soil heat and mass transport model, finite difference model, all coded up in Python. And I've learned a few tricks how to do things efficiently and effectively. So I can teach students how to do that. And then of course, after you've developed your model and you've run it, the important step is how do you actually interpret what the model's telling you? And we'll talk a lot about that. What does all of this mean? And we're really focusing on developing a critical perspective on models, what they can and cannot help us with. So that's what I'm offering. As I said, I can offer this to a range of audiences from the beginner level, where we focus more on the fundamentals and programming concepts, to the intermediate level and to the more advanced level. So I hope to hear from you, and I look forward to meeting you, your students and your colleagues in a class or workshop very soon. Thank you.